Hello everyone. In this video, I'll tell you what is correlation and regression and what is the difference between correlation and regression and what is Karl-Pearson correlation coefficient. Suppose we have two variables, variable x and variable y. We want to know which variable is dependent and which variable is independent. So basically we want to find out amongst them which one of these is cause and the effect. To find out the cause and effect relationship, first we have to find out correlation between them. And for that, to know the correlation, we plot data, and when we plot data, we find one regression line. This is called regression line or the line of best fit. Regression line or the line of best fit. When we plot data, data scatters. This is called dispersion of data. Generally, data deviates from the regression line. This is called line of best fit, and data deviates from the line of best fit. To estimate the deviation, we draw one cap-like structure on that data. And to find out whether these two variables are associated or not, first we draw correlation coefficient, and to find out the correlation coefficient we have to find out standard deviation, and to find out the standard deviation we have to find out arithmetic mean, because standard deviation can be find out with the help of arithmetic mean only. We cannot find out standard deviation with the help of mode or median. It can be find out only with the arithmetic mean. So to find out standard deviation, we have to calculate arithmetic mean first. And after that, we apply correlation coefficient. The formula of correlation, Karl-Pearson's correlation coefficient. This is called actually Karl-Pearson correlation coefficient. And the formula of Karl-Pearson's correlation coefficient is covariance of variable x and variable y divided by root over variance of x into variance of y. If we expand this formula, we can write it down: sigma summation dx into dy divided by number of data which we have taken into standard deviation of variable x into standard deviation of variable y. With the help of this formula, we find out the correlation coefficient between these two data, whether they are correlated or not. For example, if we take the data of demand and price, we can assume this is x and this is y. This is x variable and this is y variable. We want to know whether they are correlated or not. With the help of correlation coefficient, we come to the conclusion that yes, they are negatively correlated. Why? Because when price increases, quantity demanded decreases, and if the price decreases, quantity demanded increases. So we come to the conclusion that there is negative correlation between these two variables, right? But correlation coefficient answer only that there is association or there is positive or negative correlation between these two variables. It does not give us the information that whether one is cause and the other is effect. So to find out amongst them which one of these is the cause and the effect, we calculate the regression equation. Regression equation gives us two regression line, and with the help of that regression line, we find out amongst them which one variable is the cause and the other is the effect. And to find out that, we write it down: x is equal to a plus vy and y is equal to a plus bx. And after that, we calculate bxy and byx. We want to know the effect of x on y and the effect of y on x, because if we write x is function of y, it means this variable is dependent variable, and the right hand side, this variable is independent variable. Right? In our example, demand is the function of price. It means price is independent variable and demand is dependent on the variation of different prices in the market. So to find out which variable is dependent and which variable is independent, we use regression equation. And to find out the regression equation, to find out the two lines of regression, we calculate b x on y and b y on x. And the formula of b x on y, the first regression line is v x on y, and the formula of b x on y is correlation coefficient into standard deviation of variable x divided by standard deviation of variable y. Okay, and the second equation is b y on x. The formula of b y on x will be correlation coefficient into standard deviation of y divided by standard deviation of x. If it is x on y, standard deviation of x will be the numerator, and if it is y on x, then standard deviation of y will be the numerator. So this is the minor difference between them. And when you calculate the b x on y and b y on x, we can find it out with the help of correlation. With the help of these two lines, we can find out the correlation coefficient also, because there is a relationship between these two regression lines and correlation coefficient. What is the relationship is r is equal to correlation coefficient is equal to under root the first regression line into the second regression line. So correlation coefficient is under root of these two regression line also. So the difference between correlation and regression, correlation shows only the direction, whether they are positively correlated, the data which we have plotted, demand and price, whether they are positively correlated or negatively correlated. So correlation coefficient shows us the direction only, but regression equation tells us amongst them which one of these is cause and the effect. So to find out the cause and effect, we use regression equation, and to find out the direction only or positive or negative relationship only, we use correlation coefficient. Any question, you can write it down in my comment box. That's it. Thank you. Thanks for watching. Bye-bye.